Bubble sort. Bubble sort is a simple sorting algorithm that repeatedly steps through the array to be sorted. It compares adjacent items and exchanges them if they are not in the correct order. The algorithm makes multiple passes until no swaps are necessary and the elements of the array are sorted. The algorithm is very slow and impractical for most cases. At the first pass, for example, the adjacent element will be checked. If we are sorting in the increasing order, let's write first pass. 5 is greater than 4, that's why they are going to be exchanged. 5 is greater than 3, they are going to be exchanged. 5 is not greater than 12, 12 is not greater than 33, 33 is not greater than 54, 54 is greater than 7, they will be exchanged. 54 is greater than 8, 54 is greater than 9, 54 is greater than 15. After the first pass, we have this result. On the second pass, at the last position, we have the largest element. That's why in the second pass, we are not going to include that. We are going to exclude the last elements. So in each pass, one less element needs to be compared. 4 is greater than 3. That's why they will be exchanged. 4 is not greater than 5. 5 is not greater than 12. 12 is not greater than 33. 33 is greater than 7. 33 is greater than 8. 33 is greater than 9. 33 is greater than 15. And we found again the largest element in the remaining part, so 33 here. On the third pass, also we are excluding this. On the third pass, we are going to search the largest element in the remaining part again. The algorithm makes multiple passes until no swaps are necessary and the elements of the array are sorted. Let's implement this algorithm in Java. Instructions: given an array, display the array. Sort the array in the ascending order by using the bubble sort algorithm. Display the sorted array. Bubble sort efficiency is important. We are going to use while loops. That's why let's create a counter for while loop I is equal to 0, and while I is less than the number of the elements in the array length. We are going to compare with the adjacent elements. That's why we are going to make -1 pass. That's why -1 I can write here. I will be number of passes, and number of the elements in the array which will be compared, that will be j. Let's write j is equal to 0. And while j is less than a.length -1, and after each pass we should exclude the rightmost element. That's why we are going to write here -i. So it's going to be initially, for example, if it is 10, 10 minus 1 it is 9, I it is 0. After that, when I is 1, 9 minus 1 it's going to be 8. After that, when I is equal to 2, 9 minus 2 it is 7. So it's going to be decreased and the rightmost element will be excluded. We are comparing the adjacent elements. That's why aj is greater than aj plus 1. So we need to swap them. So we are going to sort the array in the increasing order. In order to swap the elements, we need a third variable. Let's call it temporary t equals to aj. After that, aj is equal to aj plus 1 and aj plus 1 is equal to t. So I can show it like this. For example, we need to swap aj and aj plus 1. We need to swap. And first, we are going to have an if variable. We are going to put it here first. After that, that's t. T is equal to aj. After that, aj is equal to aj plus 1. That is second. And t is equal to aj plus 1. And we need to increase j value here and I value after this one. And we can print the sorted array after the loop. Let's use this printing section, copy and paste. And let's see the result. I is already used. That's why let's change this I to k. So we see that the array is sorted, but it is not efficient because if there is no swap, we can stop the loop. In order to do that, we are going to use a flag. Let's call it boolean swapped. Initially, it is true. And before the inner loop, we are making it false. If there is swapping, we are making it true. So if there is swapping, so swap is true. And here we should write and swapped. So if there is swap, we continue, okay? We set it to false before the inner loop. After the loop, if it is still false, when it comes here, and it's going to stop this loop. Because it's going to be false, the loop stops. Using this flag makes our bubble sort more efficient.